Welcome to DataFarm. Let's start by uploading the execution plans of your already existing Dataflow jobs. DataFarm analyzes the input workload and provides various statistics. First, the input jobs are clustered based on a user-specified similarity metric. For example, the number of operators in a job, the number of maps, and so on. In this case, we uploaded 18 jobs, composed on average by 21 operators. Then, the user can visually inspect the distribution of operators of his input workload and the learned children and parent transition matrices. By inspecting the input workload profile, we can decide to exclude some input workload from the generation process. For example, we can exclude all the jobs that contain the bulk iteration operator by deselecting the corresponding bubble. So, the learned operators distribution and the transition matrices will be updated accordingly. After inspecting the input workload, the user can choose the number of abstract plans he wants to generate, the maximum number of operators per plan, and the total number of joins per plan. DataFarm generates the abstract plans with the desired characteristics, and it displays them with an intuitive visualization. By default, DataFarm will instantiate all generated plans. However, the user can decide to discard uninteresting plans from the instantiation. Then, to begin the instantiation process, the user specifies how many diverse instances he wants to generate per abstract plan. He provides a metadata file that contains information about the input data, such as the entity relation schema of the database, the row cardinalities of the input tables, and so on. And finally, he specifies the target data management platform where the generated jobs will run. DataFarm returns statistics about the generated workload. In this case, we generated 100 jobs, composed by 26 operators on average, and with an estimated average output cardinality of 2.5 million records. Then, it provides the comparison of the operators' distributions between the input and the generated workloads to assure their similarity. Finally, it shows how the generated jobs are distributed concerning the input-output cardinalities. This demonstrates that the generated jobs are covering most of the input-output user's data domain. At this point, if the user just needs a benchmark for his data management system, he can stop here, downloading the set of generated jobs. In contrast, if the user requires labeled jobs, for instance to train an ML-based optimizer, he can proceed with the efficient labeling process provided by DataFarm. Here, the user specifies which is the target label that has to be learned and the initial number of jobs that have to be executed to initialize the process. Then, he provides an uncertainty threshold required to identify early stops in the process. And it defines the maximum number of allowed iterations and his time budget. In this case, DataFarm identifies an early stop after executing 16 jobs. After the early stop, it returns a visualization with all the jobs and their certainty level. The user can then zoom in to observe each specific job. DataFarm provides also details about the trend of labels uncertainty observed up to the current iteration. If the user is satisfied with the result, he can download the training data. Or he can decide to execute more iterations to further decrease the uncertainty of the forecasted labels for each generated job.